I'm Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are going to see how to solve questions related to trigonometry, compound angle formula. The questions are being shared by my student Amy. Hi Amy, how are you doing?
Hi, sir. Yeah, I'm all right, thank you. How are you?
Very good. So how's your Christmas break going on?
It just started, so it's quite nice. I kind of started off the break meeting a lot of family and everything, because apparently they're trying to make the COVID restrictions much tougher in UK, so we can kind of see another lockdown coming. So before that happens, trying to meet up with everyone just to get together, which would be nice. So
Good,
yeah.
good. So
How about you, sir? How's the Christmas?
very good.
Family.
We are also doing the same thing. We are in the same boat.
All right.
Yeah. Waiting for the lockdown once again. It's like partial at present. Perfect.
Right. Yeah.
Okay. So, how is your math study? Is it on hold or is it going on?
Oh no, it has to go on because I've got a quite a big test after the Christmas break, which they might consider for our, because we're not sure also about end exams and that all these like little major tests in between will definitely be taken into account. So I need to make sure it ends up quite well. I did write a list of topics that test will include on this little post-it note, so I can just have it in my head what will come up.
I like your approach. That's great. Putting a stick there.
Yeah.
Stick note there.
Every day when I look, I'll just like remind myself.
Constant reminder. Beautiful, beautiful.
Yeah.
Okay, then share whatever you have. We'll go through it. Right. And let's see
I think,
how it can help.
yeah, like last time we always did it by I guess by topics, and then after I think there's only four-ish kind of topics, and one of them was already done like in the last test. So then after we do that, I can maybe get like a whole document of random questions of all four of these, and then that'll be really good just to test it, because when it's all in one document, it's quite easy.
Easier it is. Correct.
But yeah. I got a couple from here, and then so the topic today, do you think we could cover compound angle and double angular formula as well?
Sure.
Also the alternative form.
No problems. Yeah, we can do all this. Yeah.
Just a bit of trick.
Are you familiar? Do you remember? Can you recall all your compound angle formula? Because we should have a list of the formula on the side. If you want, we can just derive them quickly and then attempt questions one after the other.
I do remember them.
You do remember? Great. Okay. So in that case, let's start with the very first one. And if, in case required, we can always derive the formula. Not a big deal. Okay. So very first question, can you read and then we'll try to answer this.
Yeah. So solve the equation sine x plus 30 equals 2 cos x plus 45, where x is between 0 and 360 degrees.
Correct. So how will you do it?
So I just would use the formula of sine A plus B. Correct. And when you expand that, that would just be sine x cos 30 plus cos x sine 30.
Correct. And then you have this special triangle, 30 degrees is given to you, which is right here, right? In this special triangle, correct? So you know the value of sine 30 and cos 30. We know sine 30 degrees is from here half, and cos 30 degrees is square root 3 over 2, correct? Right. Substitute those values. So you will have an equation in sine and cosine. So once you have that equation sine and cosine, then how will you solve it? You'll just divide and get tan, right?
Yeah.
Right. So this is simple. So you'll just write sine x cos 30 equals to 2 times sine x cos 30 plus cos x sine 30 equals to 2 times, let me write in brackets, cos x cos 45 degrees, and then minus sine x sine 45 degrees, correct?
Yeah.
So from here, you can substitute the values which we just saw here. So sine x times cos 30 square root 3 over 2, just substitute that value here, plus cos x sine 30 is half equals to 2 times cos x cos 45. Cos 45 is 1 over square root 2.
Yeah.
Square root 2, right? And minus sine x, and that is also 1 over square root 2. You can also write square root 2 over 2. So that is a better way of writing it, right? So for, let me write this as square root 2 over 2. It's to rationalize, it becomes square root 2 over 2, correct?
Yeah. Because you don't want to set at the bottom.
That 2 cancels, right? That's the whole idea. Do you see that? So that 2 cancels, and now we have the terms with sine x and cos x, correct?
You can get like terms by expanding.
Yeah.
Like terms.
Like
and
terms,
then find tan.
And then find tan, correct. So rearrange. And
I did, yeah. That was fairly straightforward.
And get the error value. Within 0 to 360, is that right? So when you find the tan between 0 to 360, use your cos rule, right?
Yeah.
Depending on whether the tan value is positive or negative, correct? You may have 2 solutions within this 0 to 360 degrees, and then you get full marks. You get the idea, right?
Right. Yeah.
So let's move on to the next question. Can you please read that?
Yeah. So if 4 cos 2x minus 2 cos x plus 1 is 0, find the values for x in the range of x between 0 and 360 degrees.
How will you do this one?
So since the equation as a whole is in terms of cos x, I know that the cos 2x has like 3 different versions, but I want the version that is only in cos squared. Since, so 2 cos squared x minus 1 is what I'll sub in.
So sub in this value here, then you have a quadratic equation in cos squared x and work it out, and then you should have 4 solutions in this case, right? Because when you have a quadratic equation, plus and minus, right? So you expect 4 solutions here.
Nice and straightforward. Yeah.
Next question, please.
Question 3. So this is writing 3 cos theta plus 5 sine theta in the form of r cos theta minus alpha, where r is greater than 0 and alpha is in between 0 degrees and 90 degrees. Hence, solve the equation 3 cos theta plus 5 sine theta equals 2 in the range of theta, where it's in between 0 and 360 degrees.
8 marks.
2 parts. Yeah.
Yeah, 2-part question. So in the first part, you have to write this as a cosine function, correct? So we also call a simple harmonic wave equation, right? You remember that?
Right. Yes, I do.
Yes. So basically, 3 cos theta plus 5 sine theta is to be written in the form of r cos of this, right? So the value of r could be 3 square plus 5 square square root. Yeah, do you remember that part?
Do I remember? Yeah. So where you, to find r, you do a squared plus b squared square root.
Correct.
And then you find tan alpha, and then you find alpha and sub it in.
Correct. We know this is r cos theta and r cos alpha, right? That's the whole thing, right?
Yeah.
So you get the value of r, and what is alpha equals to tan alpha. So you said right thing, which is, let me now write down here. So tan alpha, as you said earlier, is basically equals to 5 over 3, right? So alpha equals to tan inverse 5 over 3. Can you calculate? Tell the answer.
So it's 59.036.
So we'll keep 59.036 for now, but we'll use 59 degrees in our answer. But when we have to just write it r cos alpha, correct? And r value we already have. So we have this function as equals to, we can write now 3 cos theta plus 5 sine theta as equal to r square root 34 cos of theta minus 59.036. Let me write like this, but you can round it to 59 degrees in the answer, right?
Yeah.
But you have to calculate this value. Now, 3 cos theta plus 5 sine theta is equals to 2. So part 1 is done for you, correct?
Yeah.
Perfect. This is 1. And now equate it to 2. Equate this to 2, right? And so we have cos of theta minus 59.036 equals to 2 over
2 over root 34.
Yeah. So find the related acute angle beta. What do you get?
You get 69.94.
Very good. 69.94. Good calculations, right? So we got this angle. Since we know it is positive, right? Since it is positive, we have two solutions within the given domain, right? And those are in the quadrant 1 and 4, right?
But would you need to change the domain, like subtract 59.036 from each of those, like from 0 and 360?
We will check the answer, and
Okay.
that we can add the period. You get the idea.
All right. Yeah.
So we can do it the other way also, right? So the related acute angle 69.94, let's say 70, right? For now, 70 degrees, right?
Yeah.
You could use 69.94, and we have the other one as 360 minus 70, which is 290 degrees, correct? So I'm just rounding it.
Yeah.
290
Yeah.
degrees, right? So now find theta. So theta equals to, when you say theta equals to what? 70 plus 59.036, correct?
Yeah.
So theta will be, because that goes on this side, 70 plus 59, let me write down, right? Because we use 59. And that gives you 9 and 7, 129. That is within the domain. So that's fine with us, correct?
Mm-hmm.
The next one is basically 290. And if I add to 290, 59, what do you get?
So add 59.036. We don't need to do that. We just need to do 59.
Yeah.
Oh, okay.
We rounded the other value. Yeah.
Okay, so you got 349.095.
So whatever you get, so 349 is also within the domain. You get the idea.
Yeah.
Because the domain is 0 to 360 degrees. So we got both the angles, correct?
Right,
but yes, right. Do proper rounding. When they are giving you a whole number here on the right hand side, 2, then you should round to a whole number, not the decimal place. You get the idea?
Oh, I see. Okay.
Sometimes they will mention on the top itself that round all your answers to so many significant figures.
Right, yeah.
In that case, round them to those many significant figures. So follow those rules, right?
Okay, so if there's numbers in the question or like in the answer section, which is to a certain decimal or significant figures, use that in your answer.
Yes, use that.
And if not, read the question carefully to make sure it's not said anywhere. Yes. Okay.
So this process is very clear to you, right?
Yeah, very clear.
Perfect. And you remember that R is A square plus B square square root, and tan alpha is B over A, and you're done. Simple as that. Correct. Next question, please.
So prove that sine 2x minus cos 2x plus 1 over sine 2x plus cos 2x plus 1 is tan x.
Yeah, that's a slightly difficult identity. Tell me, how will you prove it?
Well, I know sine 2x can be written as 2
sin x cos
x. Yeah, and then cos 2x.
Which one do you want to use?
So there could be cos squared x minus sine squared x.
Yes.
And then the 2 cos squared minus 1.
That is better. So use cos squared x minus sine squared x.
How do you know which one's better?
We got one here also. You get the idea. So let me just show you this particular thing. I was jumping to that part, and that's why I told you cos 2x is this, right?
Oh, okay.
Just look into this part carefully. So I'll do it on the side to show you. Very important thing, right? So when you say cos 2x is equals to 2 cos square x minus 1, it really means what? See, effectively, it is written 1 minus cos 2x here, right? In the numerator?
Yeah.
Right? So if I write, and it is written 1 plus cos 2x.
Oh, yeah.
Correct? Now here, look here. Cos 2x is also equals to 1 minus 2 sine square x.
Mm-hmm.
So from here, what you get is that cos 2x plus 1 is 2 cos square x. And cos 2x.
Cos 2x.
Yeah, or I should
plus
say 1 minus cos. Or let me write like this.
Oh,
Or yeah, you got it right. So I write 2 sine square x. 2 sine square x is basically equals to 1 minus cos 2x. Is that okay?
Oh, yeah.
So in the denominator where I have cos 2x plus 1, I will write this cos 2x plus 1 as this
Has
form.
2,
Cos
yeah.
squared x.
Right. 2 cos squared x.
You get the so
Oh,
now
wow.
denominator will be here. This is important. I was jumping to that actually. That's why sine 2x I wrote this. I want to write this one. So sine 2x is 2 sine x cos x. And the denominator in this case will be 2 cos square x.
Right.
The numerator is 2 sine x cos x. And it is 1 minus cos 2x, right? It is 1 minus cos 2x, correct? Because this is minus.
So you put 2 sine squared x.
2 sine square x. You get the idea. Now see how simple it is. I can take 2 sine x common in the numerator.
Oh. And then you can take cos x and make tan.
Yeah, plus sine x, right? Do you see that? Because sine x I took common, right? And then here also I will take cos x common, right? 2 cos x. And what I get is sine x plus cos x. That sine x plus cos x
cancel. Oh, and the 2 and 2 cancel.
2 cancels, so I get tan x.
You get tan.
This is the fastest way of doing it. If you go through all of the things, you get confused and you
You get
the idea.
God. So, the thing is that when you have a set identity given to you, you never think to rearrange that identity because you're so fixated on the fact that it's supposed to be only that form for some reason. I don't know why that is. It's like even the normal trig ones. We were doing the cotangent and stuff, and you were telling me to what's it? A difference of 2 squares. You can take it out like that. But I was mind blown because I was like, you don't think of it like that, So yeah,
look carefully.
Same thing applies here.
This is the beauty. I really love this question. It has come in test papers many times, not once. I've seen it in Canadian test papers, in American test papers. Yes,
it's a famous question.
It is very common. In my YouTube channel also, you'll get many versions of this question.
Cool. All right.
The key is this. That is how you should be doing. That's the beauty of solving it. You get the idea.
Yeah. It's a very satisfying question.
So straight away from here, we get to these 3 steps and we have the solution.
Wow. Yeah, I would not have thought of that. No way. At least now I know.
Fastest 5 marks for you.
Yeah. We can't be wasting those marks on, especially when they're easy things like just rearranging an equation. Yeah. But the thing is, in exam conditions, you're like, oh my God, this is impossible. I've not learned this. You don't use what you have or the stuff the knowledge that you have. You just leave it. So yeah, that was very clear. Thank you, sir.
Perfect. Next question, please.
So question 5, write sine 3x in terms of sine x.
Correct.
And part 2, solve sine 3x equals sine squared x, where x is between 0 and 360.
So that's easy, right? Sine 3x is what? Yeah. You can
write
sine x plus, you can do that, right?
Actually, sine 3x.
So write 2x plus x. Is that clear to you, right? So it takes time, but sine 2x times cos x plus cos 2x sine x, and then cos 2x is basically 2 sine x cos x times cos x plus.
Wait, how did you do the first step?
Compound angle formula. Sine a plus b. Sine a cos b plus cos a sine b.
Oh, see, what I was trying to do is you went. I was trying to get. Apparently, I was trying to get. So sine 2x, I know is 2 sine x cos x. So I accidentally went straight to that. So I was a bit stuck. Okay. Yeah.
Correct. So they want you to write sine 3x in terms of sine x, right? So now we got to this stage. So we have cos 2x and sine x. Now cos 2x can be written in 3 different ways. So how will you write it?
Cos 2x should be written in terms of sine. So 1 minus 2 sine squared x.
Correct. Multiply by sine x. Correct. and then open the bracket. So you get 2. Sin x is common, right? So let's take sin x. Let me just first open this up and then we'll figure this out. Is it okay?
Yeah.
So 2 sin x cos square x. Now,
Sorry.
since we are getting cos square x here, right? You get the idea. Since we are getting cos square x here, okay, so sin square x cos square x will cancel. Is that okay? So we can we can continue with this. Minus 2 sin cube x. And then we
Plus
have
1.
plus 1 times x, sin x. You have to multiply with 1, right?
Oh, yeah.
Sin. So we can take sin x common, 2 sin x common. And
Cos square x.
it doesn't really help you. Do you see that?
Oh, yeah.
It doesn't really help you. So in this particular stage where we were, it was better for us to use cos square x. Because then you take cos square x common and then figure it out. Because in this case, when we say write sin 3x in terms of sin x, if you get hold of cos square x terms also in it, then it becomes slightly difficult. You get the idea. Cos square x, yeah.
I thought because we want it inside, we use like.
Okay, we can still do it. We can still do it. So we have 2 sin square x, 2 sin x common. So we get cos square x minus sin square x plus sin x.
But if 2 is outside.
Pardon?
Oh, you just put that in brackets.
Yeah, put that in bracket. Correct.
Oh, isn't that the cos squared? No, cos 2x.
So cos square x minus sin square is cos 2x. Yes, but that doesn't really help you to solve this particular question. That's what I'm trying to tell you.
Oh, I see. So if we get stuck like that, we can easily just go back and put cos squared x instead.
As a sin square x, 1 minus sin square. You get the idea?
Yeah.
So if you get, because that is what I was trying to tell you, that we need to avoid that cos square x because we want quadratic equation in sine, right?
Oh, right.
So we'll again go back to this and then we'll write, instead of 2 sine cos square x, we'll write 1 minus sin square x. Is it okay? So we have 2 sin x. So we'll continue. So it's a longer, slightly longer now, 1 minus sin square x. And we still have sin square x inside the bracket plus sin x, correct? So we have 2 sin x and we have 1 minus 2 sin square x plus sin x. Now I'll open the bracket. So and
wait, so instead of so you know the part where we inserted 1 minus 2 sin squared x as cos 2x, should we replace that with 2 cos squared x plus 1? No, minus 1. Is that what you're saying to do?
No, anyway, this is not wrong. I mean, in any case, you'll get cos square x, but then write cos square x as 1 minus sin square x, as we are doing now. Is it okay? Is this step clear, Amy?
Oh, yes.
I wrote cos square x as 1 minus sin square x.
Right.
So if you get that step, cos square x, but you want sine function, then you write cos square x as 1 minus sin square x, and then continue, right? So let me open the bracket again. So if I open, you get 2 sin x minus 4 sin cube x plus sin x. Do you see that? And that 2 and 1 is 3. So we get 3 sin x minus 4 sin cube x. So now we have a sine function. You get the idea?
Right. Yeah.
So this is part 1, gives you 4 marks. And then we have to equate this to sin square x, right? So equate this to sin square x. You have sine common, bring them all together. So keep leading coefficient positive. So write this as 4 sin cube x, taking all those terms there, plus sin square x minus 3 sin x equals to 0. Of course, sin x is common. So we get 4 sin square x plus sin x minus 3 equals to 0, correct? So one factor sin x equals to 0 is a part of solution, correct? You want to include 0 and 360, and sin x is equal to 0 when? So just graph this function. So it is at 0, 180, and 360, correct? So you got three solutions right there from this, right? Sin x.
Mm-hmm.
And now the other factor is the quadratic factor. 4 times 3 is minus 12. We got minus there, right? So we could factor this out. You can write sin x as 4 times 3 is 12. So it's 4 and 3, right? So 4. So you just factor this out. Can you factor this? 4, let me write long way. Sin square x.
I can factor it.
Yeah, you can factor it. 4 sin x minus. So we need positive, right? 4 sin x minus 3 sin x. Minus 3 equals to 0. So we have
3
sin
over
x.
4 and minus 1.
And then we have here two groups, which is 4 sin x. And we get what? We get sin x plus 1. And here we get minus 3 sin x plus 1, correct?
Yeah.
And therefore, we have three factors now, sin x times sin x plus 1, or I could write 4 sin x minus 3 times sin x plus 1 equals to 0. Is it okay? So from the first factor of sin x, we got three solutions. Now, second factor, sin x is 3 over 4. So less space here. So sin x is equal to 3 over 4. Find solutions. So two more solutions for you, right?
Mm-hmm.
Sin is positive in quadrant 1 and 2. Get these two solutions, correct?
Oh, wow. Yeah.
And then we have sin x equals to minus 1, which is at 270 degrees. So at 270 degrees.
Isn't sin x equal 0 a solution?
That is also a solution. So we got three of those. So we got 0, 180, 360.
Mm-hmm.
So our solutions are 0 degrees, 180 degrees, 360 degrees, 270 degrees. Sorry. Is that correct? Plus do sine inverse of 3 by 4. What do you get?
You get, it's in degrees, so 48.59.
48.6 degrees. And then 180 minus 48.
180 minus that, you get 131.4.
So these are all the solutions. You get the idea.
Wait, minus, what about sin x? Oh, you got 270. Yeah.
Yeah, 270 error. Correct.
Cool. So we've got 1, 2, 3, 4, 5, 6 solutions.
6 solutions for this equation. You're right. You see how?
Wow.
Correct. It's a very important question. Yeah, your teacher has given you very good selection of questions. I love it.
Well, yeah, I think it was on the variety of all that trick stuff that we did, so that we can touch upon all the skills instead of just practicing the one skill for like ages, you know.
Correct. Now prove that sine to the power of 4x plus sine to the power of cos to the power of 4x is cos 4x plus 3, right? So how will you do this? We really want cos 4x. Do you see that? How will you approach?
So we'll do 2x times add 2x.
Remember this formula.
Cos 2x plus 2x is 4x.
So you could think like this also. Sine to the power of 4x plus cos to the power of 4x. Whenever they come, it's like sine square x plus cos square x whole square minus 2ab. Do you see that? So look. So look, I will write this as 4 times. Let me write like this as sine square x plus cos square x whole square. That will give you a square plus b square plus 2ab. So I've got that minus 2 sine square x cos square x. Do you see that? This is my left hand side. 4 times. You get the idea. 4 times.
Wait, I'm slightly confused.
Okay, expand this part. Sine square x plus cos square x whole square is what?
You get 2 sine squared x. Oh, 2
2
sine squared x. Yeah. plus 2 sine squared cos squared x, and then plus cos to the power of 4. Oh, okay, which is that? Yeah.
And this is what? This is just 1.
Oh, yeah.
So we get
Wow,
this
you
3, right?
simplified that so quickly. Oh my gosh.
Minus, minus, we want all cos 4x, right? So we got minus 2 sine square x. Let me first write this like this, right? 2 sine square x cos square x. Is that clear to you? Correct?
Yeah, I'm just in shock. That's why.
Now what is 2 sine square x? 2 sine square x is, look here, 2 sine square x, 2 sine square x.
It's cos
1
2x
minus cos 2x.
plus 1.
1 minus.
No, minus 1.
Do you see that? So we'll write here 4 times 1 minus, instead of 2 sine square x, I'll write within brackets 1 minus cos 2x. Is that clear to you?
Yeah.
And this cos square x, or I could, because we need degree 4, cos 2x, how much we need cos 4x, right? So, okay.
Yeah.
So let me go for cos 4x. Let me just take it the other way. Wait. Let me clear this part. I'll show you a shorter way. Okay. So 2 sin x cos x is what? Look here. 1 minus, it is saying 2 sin x cos x, right? So which is?
Oh, the sine 2x. Sine squared. No.
So half of.
Because of the square there. Does the square make an impact?
Yeah. I'll do half because I want 4, right? So let me add one step. So 2 sin x cos x whole square.
Oh, that part is sine 2x. Oh, okay. So you took the square out. Wait, how come you took half?
Huh? So because I want 4. When you expand, 2 square will be 4, right? So 4 divided by half will be 2.
Oh, yeah. Right.
So basically what I did was I divided by 2 and I multiplied by 2. Do you see that? So half I took outside, 2 times 2 I put them in the square thing.
That makes sense.
So we got square of sine 2x. So we got 4 times. So you can try this out. 1 minus half of. This is like sine 2x. Sine square 2x. You get the idea.
Yeah, so that's the same as 1 minus half times sine squared 2x.
Right. So sine squared 2x. Think 2x is theta, right? Think.
Yeah.
2x is theta, right? So if I open the bracket, because this is like 4 is already there for me, right? 4 is already, so 4 minus, open the bracket, 4 times half is 2, right? 2 sine squared 2x, correct? So what is minus 2 sine squared x?
Minus 2 sine squared x is cos 2x plus 1.
Cos 2x. Now 2x is 2x. So twice that means 4x, right?
Oh yeah, cos 4x plus 1.
Minus 1.
Minus 1.
Correct?
Yeah.
So now you get your thing, right? Because it is 4 minus 1 is 3.
Wait, we had minus 2 though.
What?
We had minus 2 sine squared 2x.
Why minus 2? Yeah, minus 2 sine square x. So minus 2 sine square x is cos 2x minus 1. Look here. Bring this 1 on this side. So it is cos 2x minus 1 equals to minus 2 sine square x.
Oh, I see. So it's cos 4x plus 3.
No. We again open the bracket. So 4
no, I mean like the final answer, cos 4x.
Oh, yeah. Cos 4x plus 3 as the right hand side. Yeah.
I see. Oh, yeah. Yeah. So the tricky part, so when you expand, so when you square something,
Yeah.
The 2 is being squared to 4, and then 4 divided by 2 is 2. Is that what you said?
A square plus B square can be written as A plus B whole square minus 2A. You get the idea. A square plus B square is A plus B whole square. This square is A plus B whole square minus 2AB, correct?
Yeah, that's clear.
So because this was to the power of 4, so we get sine square theta plus cos square theta is 1. So we use that strategy to cut down few steps, and it becomes much simpler.
Oh, I see. Yeah. So that was very important.
Even at this stage, it was better for me to open the bracket because, I don't have to really multiply and divide, right? Because 4 times 2 is 8. I will take 2 outside and 4 inside.
Oh, yeah.
So it becomes, I opened the bracket later, but I should have done it here itself, open brackets.
I think I'll just open it in ahead of time, only because that kind of may confuse me a little bit, but it all applies the same. So yeah.
Correct. So you can look into like how could we approach in the examination. We can cut down a step here, so there is no confusion at this stage. It's clear because working with fractions become tricky at times. For some students,
definitely
it's difficult.
Yeah, no, for me definitely it's difficult. Yeah.
And then here we maintained minus 2 sine square x on the right hand side. Do you see that? Because we had minus 2 sine square x. Why should I bring it and then invert and do all those things?
Yeah.
I am substituting minus 2 sine square x. So let me keep this as minus 2 sine square x.
Yeah, just to avoid any issues with the signs. Yeah.
So that ways we could actually get faster and better solution.
Because you never ever think of doing minus, keeping the minus with it. You would take the 2 sine squared x and then deal with the minus later or something, and that can lead to error.
Correct. So is that clear to you?
Very clear. Yeah.
Good job. Next question, please. 6-2. Okay.
Last one.
Then we have to just simplify it, solving this equation.
I think I can, do that. Once the hard part's done, that's fairly easy.
4x. So when you have 4x, that means there are 4 cosine waves within this 2 pi. Is that clear to you?
Oh, so solution-wise, we're looking at 8.
Yeah. So let me just sketch this. You find the solutions later. So cos of 4x is equal to what have they given you? 0.5. So I'll take this on the other side. So it'll be negative, right? Somewhere. So we're looking for these solutions. So
1, 2, 3, 4, 5,
1
6,
wave,
7.
2 wave, 3 wave, 1 more wave, right? Do you see that? 1 more wave. So we get all these solutions, 1, 2, 3, 4, 5, 6, 7, 8 solutions. So you are expecting 8 solutions here. Is that clear to you?
Okay, yeah. All within the domain. It's in radians as well. Okay.
Right, 8 solutions. Perfect. Let's move on to the last question. That's good.
It's good timing.
Yeah.
So find the minimum value of the expression 4 cos x minus 3 sin x minus 4.
Yes.
Give the smallest possible positive value of x for which the minimum value occurs.
Correct. So basically it relates to your first question. You get the idea? 4 sin x minus 4 cos x minus 3 sin x. You could write this as r cos of, write this as r.
Can't you write, does it matter if you do cos like theta minus alpha or?
No, if this is minus, then you'll get plus a, right? Because cos a plus b is cos a cos b minus sin a sin b. You get the idea?
Oh yeah, with cos it's invert, the sign is opposite, whereas sin it's the same.
Correct.
Understood.
So use that and then get your result. You get the idea?
Yeah,
so you write this, and definitely we have r is equal to the square root of 4 square plus 3 square. 3 square, right? 16 plus 9, 25. So 5, 3, 4, 5, correct? So we have this.
Where does the 4 come from?
Oh, 4 and 3.
Oh, I mean that minus 4.
Which minus 4? Where did I write?
No, you didn't write. Just in the equation, 4 cos x minus 3 sin.
They just wrote it. They say, yeah. Yeah.
Is that to trick you? Because if I saw that, I wouldn't have done like the harmonic wave formula thing.
No.
Because usually they don't do that.
This part is harmonic wave minus 4, right? They want you to have a minimum value. So R value actually gives you the amplitude. -4 will be your minimum value. Do you see
Oh,
that?
I see.
It's
Yeah.
translated 4 units down. Is that clear to you?
Right. So yeah, vertical translation.
Correct. So remember, it's good to write here that you have cos of alpha equals to 4, sine of alpha equals to -3, correct?
Yeah.
That's given to you. So you get this. And so you can find what tan of alpha is, right? So tan of alpha equals to -3/4. Find alpha, which is tan inverse of -3/4, correct?
So very clear. Yeah.
So you get this angle. I mean, I should have drawn here and get this angle, right? Okay. So, but we'll change the sign. So minus sine theta. Wait. We'll just change the sign, right? So write down tan alpha equals to 3/4. Find the value because we are changing the sign, correct?
Yeah.
So tan alpha is how much for you?
We're getting 36.86.
36.86. And R is 5, right?
R is 5, yeah. Because of the special, no, was it 3-5-4-5 triangle?
Correct. And so we have this equation, which is 5. Let me write first as R of cos, because we did minus angle. So we have cos of x plus alpha.
5 cos
minus
x plus 36.
X plus 3686.
Yeah, -4.
So minimum is, see, this is for 5 and -4. You have to go down, right?
Mm.
So on this particular graph, you will notice that when you kind of sketch this, the function actually comes on this side and it is going down 4 units. Do you see that?
So to know the minimum, do you have to sub in x's?
No, just for amplitude minus go down 4 units. So -5, 9. Do you see that? Kind of like this. This will be -9. 4 units. 5 down, right? 5 up. 5
Yeah.
is the amplitude. Do you see that? So minimum is equals to x's, which is at -4, minus the amplitude, which is -9.
Oh, yeah. Very clear.
Then you use the equation to find the first minimum as it is. Give the smallest possible positive value of x for which this minimum occurs. Do you see that?
Yeah, so make that equal to, yeah, that part.
Yeah. So that is how.
Wait, do we make that whole equation equal to -9?
Yeah, the whole equation.
Yeah, then solve. Mm-hmm.
Yes.
Cool. Okay.
So you got 50 marks.
Yeah, it's not an assignment, but if it was,
Yes.
I understand it very thoroughly.
Perfect.
So that's good.
Okay, so we are done with this. You can summarize your learnings. We'll end the class here.
So we touched upon the trig, the compound angle formula, the double angle formula, and also the alternate form, or like the wave harmonic motion formulas. So I guess the thing, because we've already touched upon this before, but when you want to recap, I used to like lower down the year group, or I always used to like go back to the books and learn all the notes again. But the thing is that once you start doing exam questions, it just kind of comes back to you. So you don't need to waste time doing the recap of notes when you can go straight to the exam questions. That's what I love about maths. You can just go straight there. So all we needed to do was have the formulas roughly in our head what it was, and then incorporate that into each question. And yeah, there was especially in this video, there were so many new tricks and like ways of dealing with the question, which I didn't like think of at all. So especially when it's to the power of 4, I would have tried to do like y equals something squared, and then try and solve it like with some quadratic thing. But it's so much easier if you think of it as what was that thing? So you said a squared plus b squared equals a plus b squared minus the 2ab.
Yes.
So if you take that part out, then like we saw, the sine squared plus cos squared in the bracket just equals 1, and that was so nice for that to be squared 1, and it just makes everything so simple. So stuff like that really help you answer these questions. So I think that really did a nice solid recap of this whole trig topic. So that can be one topic down, just 3 more to go.
Yeah, that's
so thank you, sir.
My pleasure. Okay, so next time we'll go through the next topic. Which one do you want to select next time?